You know, I like the startup part of this because I've done 11 startups. I talk about 7 of them. 2 of them are actually in this space. One, a company called SensorLogic, was sold to Gemalto, one of the largest companies in the cellular space for SIMs on phones. The second company, called Ublip, was sold to Numerex about 4 years ago. And I became the Chief Technology Officer of Numerex. I'm also the former chairman, thank goodness, of in the standards work in M10 of the TIA TR50, Smart Device Communications. And I'm currently the chairman of the Global Standards Collaboration, which is part of the United Nations in order for us to gain collaboration. It's called the MSTF, M10 Standardization Task Force, and there's 14 worldwide standards organizations that we try to bring together in order to create standards for things to talk to each other. Because really, if emerging devices are going to take off like they need to relative to getting to billions and billions of these connections, as you know, wireless started happening when standards started being deployed. You know, Glenn asked that question about how many people have been 20 years. I actually started in 1979 at Motorola designing some of the first 800 megahertz of cellular systems. So I've been in the gig for a bit. Numerex is a 17-year-old company. We've been in the M10 business strictly for all of those years. We have about 1.6 million devices on our network, and currently I'm excited to say that we're adding about 1 every minute to the network. The M10 markets have been described to this point. These are some of the markets that I believe there's a lot of traction in now. We particularly spend our time in supply chain and logistics, healthcare, and security. And really what I'd like to do is open up the conversation a little bit to not just emerging devices, but the entire ecosystem of that device, including, like Glenn was talking about, you know, in the security market, it's not just the device, but it's also the application. And in fact, it's the network in the middle too. And AT&T is a close working partner of ours on many of these types of DNA, device, network, and application solutions. And what I'll do is I'll tell you a couple of stories about some projects that we worked on, which I hope will give you an idea about what's happening in the industrial side of the market rather than the consumer side of the market, give you a different perspective. Sensors are very important. There's a lot of things that have happened in sensors in the last years, particularly with MEMS sensors and some with nanotechnology. A lot of things that are going on in healthcare with embedded sensors and sensors outside the body and inside the body. And that MEMS capability and the very large-scale integration, along with that, you know, on a single chip, will enable a very low cost and, in some cases, no battery because it will do energy harvesting from its host and be able to transmit via short-range wireless to a hub device that may transmit back then through a wide area networking interface, for instance, through the cellular network or through Wi-Fi hotspots or through some of the white space technology that's being developed. And what we're trying to get to is an incredibly connected universe of these devices, and I believe that that's when you're really going to see this market take off because of the network effect relative to devices. And part of that also is this idea of the social network for machines. In addition to that, though, there's going to be required, because of the numbers and masses of these types of devices, some new algorithms developed. And I put this slide up because I'd like you to think about the problem of when you have a large fleet of vehicles and you want to be able to do the traveling salesman problem of figuring out what the optimum route of those vehicles to be able to go to. The problem is in computer science, I call it an NP-complete problem, which is you can't solve it in regular time. And so what you need to do is go towards more interesting algorithms. And so I believe that this ecosystem of the emerging devices will include a middle layer, which will include some very interesting algorithms. One of the ones I worked on my PhD was the ant colony optimization for solving the traveling salesman problem, which in fact, it turns out that if you put ants at the bottom of a lattice framework, they will optimally find the food source at the top. And if you mimic that in computers, you can actually solve that traveling salesman problem using some of these algorithms. But in addition to that, social networking is important, and social networking in machines is also important. And I bring up Weatherbug. It's been around for a long time, but here's the most interesting and I think fascinating part about Weatherbug. And that is what it started out is basically a weather station that went on junior high schools. And then they started going on lots of junior high schools, and they started taking that information and putting it into centralized servers. And it's interesting that NOAA now reports that it actually has a more accurate representation of the weather in the United States than NOAA. And that's fascinating because it was something that happened from the ground up rather than the top down. At Numerex, we also do satellite. We actually monitor a lot of FEMA's assets through satellite communications. And what's interesting about this particular thing is the fact that the opportunity within the space is really not just being able to tell you where a particular asset is, but the data mining that you can get out of those assets moving around is incredibly valuable to be able to tell you how to optimize things when the next hurricane hits. And that's really where the top of the value is when you move up this value system, which is kind of what I call the Maslow's hierarchy of telemetry needs, where down at the bottom of the hierarchy is just get me the data stupid, and at the top of the hierarchy is really business intelligence and optimization. But what the problem we have today within the machine-to-machine space is that you have vehicles like this that have islands of automation with many different points, and most of those points don't have anything to do or even they don't even share wide area networking in order to get that sensing data back to mothership. And so part of our challenge, particularly within the standards organizations and within the collaboration between a very complex value chain, is to be able to take that information and fuse it together to be able to make decisions. We have a customer called MicroMed that we've recently announced that we've been working on for quite some time. And this is really a fascinating application of machine-to-machine because what we've done is we've helped MicroMed provide a managed service solution for them which allows patients, instead of to be connected to the hospital or connected to their home, they're now mobile. And this is an implantable heart pump that goes inside the person. And then there's a device that goes on the belt. And then we have a wireless device which is part of that belt that we help design, including complex antennas and the capability to be able to remotely monitor this particular device so that this person can be remote and mobile. And so that you can have event processing and exception-based processing instead of wait till you get home and then I'm going to find out whether the thing's working properly or not. I love this slide. So, it's not a trick question. What's the most valuable, profitable item in a Walmart superstore? How'd you guys know? One of the biggest problems within that particular supply chain of logistics is the fact that ripening houses are very expensive. And in fact, the loss of bananas is incredible. And so the opportunity to be able to have bananas at exactly the right ripeness when they arrive and not have to have refrigeration trucks burning a bunch of energy in the back of the parking lot and then moving them in after to get to the right ripeness is a major problem. But trying to get them from Honduras and timing it exactly right is not easy. And so the opportunity to be able to take, for instance, a gas nitrogen inside of a container that's being shipped from Honduras and have that remotely controlled Wi-Fi in the yard, through cellular as it goes to the port, through satellite as it goes across the Gulf of Mexico, back to cellular as it gets within the Gulf of Mexico across some of the oil platforms that are there in the Gulf of Mexico, back to a cellular network inside the United States, back to the Walmart superstore. And in the whole way, being able to control the process because you can read through MEMS sensors the ripeness of these bananas because of the sugar content. And it turns out you can also read it from the partial pressure of nitrogen and oxygen because bananas are the opposite of humans. I didn't know that until I got into this. That's the interesting thing about this space. I know more things about chicken farms than you want to. What's also interesting about this space in the sensing side is how many different sensors there are that actually can be repurposed across many different applications. One of the sensors that we developed is basically a sensor that's two pieces of it. One is the sensors that you find when you go wash your hands. The infrared sensors that are basically a proximity sensor. And the other one is the little camera that you find on your phone. Turns out the camera chip is only about $2. And so by putting these sensors inside of bins, for instance, to be able to not only sense how full the bin is, but also to do visual verification of that bin, by having, for instance, a visual sensor every 6 inches for, in some cases, applications of 40 feet, or having wireless sensors that basically glue up to the top to be able to look down to figure out whether or not a car is in a parking space, and be able to get those costs down so low because the sensor is very inexpensive, and the energy is very inexpensive, and the wireless communication is very inexpensive. All of a sudden, all kinds of new opportunities emerge relative to this new world of connected devices. And what's interesting about the sensor that basically in this particular case is for document management, in the bin case, to be able to figure out whether the bin is full or empty, but also whether the top's open or closed, and whether or not you need to empty it, or whether somebody's breaking into it. But you can take that sensor then and turn it on its side, and you can put it on a pallet. You can put other sensors on the pallet to be able to transmit information back. And one of our customers with the capability to be able to know the position of this pallet anywhere in the world. And so part of the problem relative to the communications is not only the device side with the sensors, but also the network side. The network side where you need to solve the problem, for instance, of doing global roaming. Except you want local roaming charges instead of global roaming charges. And multi-MCs, and having your own HLR, and doing things on a GGSN, and all these other 3-letter and 4-letter acronyms that I've had to learn over the last 4 or 5 years. And then you take that same sensor, which is in a bin, and you turn it sideways, and all of a sudden you have the capability to monitor your shelf. Okay? Lots of different applications. And the last application I'd like to talk about is the optimization relative to oil field. Interesting application, and that is you have basically trucks that need to go out to oil platforms and pick up there's water and there's oil. In most cases, you worry about the oil and you pour out the water. And you have so tanks that are remotely in places that typically don't move. You have trucks that do move. And what you want to do is you want to optimize the problem of taking these trucks and going out and emptying those tanks. That's what you think you want to optimize. That's not really what you want to optimize. What do you really want to optimize for this particular case?
Oil production.
Yeah, money. Yeah. What you really want to optimize is, in fact, you want to limit oil production when you have low prices of oil, and you want to maximize your oil production when you have high prices of oil. And the way you do that is at the bottom layer, you get the data stupid, which is you have these monitoring devices on these vehicles to know how full the tank is and where they are. You know exactly where the tanks are. And then you have the location, the level of the tank. And now you also take information like screen scraping from the Houston Ship Channel, the current crude price. And you take that and go through an optimization algorithm to be able to say, you know what? This is where I need to go in order to pick up oil, in order to drop it off, in order to optimize my profit relative to oil and gas. And so one of the things that's going on within this business, and I've been in the machine-to-machine business for about 10 years, is that finally we're getting to the point where enterprises are trying to think about how to optimize their business relating to just get me the data stupid. So they're moving up the food chain into a very, very high valued opportunity. Thanks very much.